Watch Mr. Wizard. That's what all the kids in the neighborhood call him because he shows them the magic and mystery of science in everyday living.
Mr. Wizard!
Hi, Rita, come on in.
Hi.
Hi.
What's
See
that?
Well, see the image I have there on the wall?
Yeah.
Well, that's a test tube, and I have a little blowtorch on it so that you can see what happens very clearly when something boils. Because that's what we are going to investigate today, is boiling. Have you ever watched a pot boil?
Many times, but you're not supposed to watch it or it'll never boil.
That's right. The saying is, a watched pot never boils. Well, today we're going to watch pots, and I think we're going to see many more interesting things about boiling than you thought possible. In fact, here, let me stop this. And come around over here and see a pot boiling. Go around on the other side, because I have a thermometer over there so that you can read what the temperature is at the same time that we're looking at the pot boil. Now, first thing I'm going to do is, there's a pot boiling, right? First thing I'm going to do is stop it from boiling by adding a little cold water. Now, you hear that?
Cool it off.
Yes. Now get down and look, see what's happening.
Noise.
Have you ever heard that before, that noise?
Yeah, many times you heard it. But
Why?
Why does it make that noise?
Yes. Why does it make that noise? That's the first question.
The bubbles are coming up, making some noise.
Yes. You see those little bubbles coming up from the bottom?
Mm-hmm.
But notice they don't go up to the top.
No, they just disappear. Well, sound has to vibrate, so those little bubbles are vibrating.
Sound, in order to make a
Yeah.
sound, something has to vibrate. So it's probably the noise is coming from those bubbles.
Mm-hmm.
And if you want to try this at home, get a pot boiling, then add just a little water so that you can get it to stop. And look very closely at those bubbles.
That's making the noise.
That's making the noise. But why?
Just wants to make noise.
Is the water
There's gotta be
boiling, by
some
the way?
reason.
Here's a thermometer.
Well, it should be 100 degrees centigrade, and it's
Yeah.
not quite it. It's about
What is it?
95.
95. So the water isn't boiling yet. Yet where's that noise come from?
I'd call that boiling.
Well, it's
The noise?
by definition, in order to boil, the water should be at 212 degrees.
Yeah, it should.
Well, we're
It's
not. We're not measuring the temperature inside the bubbles. We're only measuring the temperature outside the water. And notice that the water is not at boiling temperature. And that's the
And
clue.
it's still doing that.
And that's the clue.
Why does it make the noise?
Well, let's see if I can show it to you over there with that test tube that I was boiling. And you'll be able to see, I think, why it makes the noise. Come around over here. And take a look at that test tube. That's water which I just had boiling as you came in. I'll light my torch and have you take a look at the test tube first so you can see what it's like. Now here's the test tube. Here, see it?
It's flat.
It's a sort of flat test tube so we can see through it pretty easily. And I'll add a little water, cold water, to make sure that it's not quite up to boiling, just like I did over there in the pot. Now when I stick it here in the projector, see, we shine light through it, and we can see what happens now when I'll hold the torch in here, and you notice now when you hear a sound, and tell me what's happening there on the screen.
There it is, yeah. Right over here.
What's happening?
It goes on and off. It makes that noise. It's making that noise again, but why? It's just going on and off.
Well, now what do you suppose those bubbles are filled with?
Well, it'll be filled with the steam if you're heating it up.
Yes.
It'll be boiling.
And now how about the temperature of the water? Remember I added some cold?
Well, if it's cold, it should be warm, though, to boil, isn't it?
Yes.
100
So
degrees?
the point is the bubble fills with steam.
Mm-hmm.
And it's getting too hot again. And then what happens when the bubble goes out into the surrounding water, which is not at 212?
Oh, you have cool water here, so that would make it contract.
Yes. So that makes the
I
bubble
see.
collapse.
So you have a bubble here, and
Yeah.
then when it gets to the cold water, it collapses.
Okay, now do that fast.
Fast?
Yeah.
You mean it makes the noise? That makes the noise.
Yes,
It'll be
that
very
makes the
fast,
noise.
I see. It's the cold water.
And when you have many of them, like you do in the pot, well, you get quite a bit of noise. So when you first,
Yes, I see.
when you first
Yeah.
get the water to boil, I'll go down here where it's a little cooler down at the bottom. Yep, still too hot. Well, now, notice that these bubbles, as I got them to form, collapsed very quickly, as you can imagine they would, you know,
Cold
because,
water.
because of the relatively cold water. But I did this exact same thing, but took motion pictures of them. There, you see them? They're really
Yeah, they're
exploding.
really hot. Could you take motion pictures of these?
Well, let's assume that this was a motion picture instead of a direct projection like it is. If you shot motion pictures of this and you projected it on the screen, you'd shoot them at 24 frames a second. And you'd see that, just as we did there. However, I have a special camera, and instead of taking it 24 frames a second, I took them at 2,400 frames a second.
It would go fast, wouldn't it?
The film goes through the camera very fast, but then when you project it on the screen, the film still goes through the same speed as though you had taken it normally. So what you do is to take time and slow it down by about 100 times.
Is he boiling at 100 times slower?
Yeah, 100 times slower than it actually occurs. And that's what you and I are going to look at, some pictures of it. And before I do it, I thought I'd show you the camera so that you can see how that works. Here's the motion picture camera that you take the high-speed pictures with.
It doesn't look difficult.
Well, it doesn't look like anything other than a normal camera, except when you begin to take a look inside. I'll take the lens off. And the door. And let me turn it down here so that you can see, first of all, in the front. Instead of having a regular shutter like a regular camera does, you look right in there, and I'll move the film.
A piece of glass.
Yes, you see that? It's a four-sided prism. And inside here, as that prism turns, you see how it's turning? You can see the slot there. As that prism turns, it's letting light in to hit the film. And the prism never stops. It just keeps going round and round. And the film goes by at exactly the same rate.
So you take a picture.
Yes, so that ordinarily, when you take a picture with a motion picture camera, the film stops and starts, stops and starts. But in this case, the film never stops. Once it gets going, it just continues to go, and it goes at exactly the same rate as the prism, so that you continuously take pictures without the film ever stopping.
I see.
Now, have you got your glasses?
Yeah,
Or you got them on?
Okay. Safety glasses?
Well, we're going to use them as safety glasses because I'm going to run the film for you to show you how fast the pictures, what the speed is that the pictures were taken at. And ordinarily the side is on the camera so that you don't have to worry about it, but I'm going to leave the side off so that the film may go flying around when we finish.
It does?
See these two marks? I put those on the side of the film so that you could see how fast these things are going. I'll start them like that now. You've got to make sure that the film is nice and tight before you start. Now this has a motor on the side, and when I push a switch here, automatically it will go, and automatically will stop as soon as you run out of film. Now if you had 100 feet of film in a regular motion picture camera, it would take 2 minutes and 46 seconds to run all the way through.
But this is faster, isn't it?
Well, you'll
With
watch.
The prism.
The camera will go on long after the film is finished, but as soon as you see the film go spraying out, why then you'll know that that's the end of it.
Okay.
Okay, are you ready?
Mm-hmm.
Here we go.
It really went.
So the
Yeah.
film went through the camera in about 2 seconds or so.
That's pretty fast.
Pretty fast. You see why I wanted you to wear safety glasses.
Yeah.
Well, now, using this camera, I took some pictures of that test tube with those bubbles, collapsing. And I can put them right here on this screen. So I'll put this out of the way.
It really went fast.
Didn't it, though? Here, you want to get on this side because I have a switch over here, so I can turn on the projector, and we can watch the film now of this. Now, watch right in here where the bubbles start forming. There's one. See, a little tiny one. There's a big one. Now, watch what happens to it as it goes up.
Starts changing. It's getting smaller, smaller.
It's in the cool water, right?
Yeah. That would make it contract.
Yeah, there it is. See it? It's finally going to disappear.
It would be making noise now then.
Well,
As it contracts.
why does the bubble collapse? Now, it's filled, first of all, with steam at 212 degrees right there.
Right.
Okay, now what happens when around the edge here when the water is cool?
Well, the cool water is making it contract.
Yes. See they join together that time?
Yeah.
And it's not just a bubble opening and then closing quickly. You see, it's a very complex sort of motion. Okay, you get the idea on that one?
It's the cool water that makes it contract.
Okay, so whenever you see a pot singing like that, you know it's
Yeah.
bubbles collapsing. Well, now, let's look at the boiling again. And now this time I'll let it boil. Let's see what the temperature is. See, I put a mark
Yeah.
there so you can see?
Yeah, it's boiling now.
Okay,
30
now
degrees.
look closely at the boiling. And notice that there is a stream of bubbles coming up.
Yeah, they seem to come up at the same spot each time.
Yes, you see, there's one stream constantly coming up from the same spot all the time. Did you ever notice
Why
that?
would they do that? I noticed it lots of times when it happens, even in drinks and soft drinks. The bubbles come up at one point.
Yes. In other words, when you have a soda or something, the bubbles seem to come up at one point. Well, it's somewhat the same idea, yes, and here too.
But why would it want to go in one spot? Why not? Why isn't one spot as good as the other?
Well, now you notice it's kind of hard to see the exact spots here in this sort of a beaker. So I'll do the same thing over there in that projector with the flat-sided test tube, and you see if you can figure out for yourself, because I'll give you a clue when we get over there. All right?
Okay.
I'll have to light the torch again. This time I won't add any cold water so I can really get it to boil. See where the bubbles are collapsing right there?
Yes. When it hits the cold water, it starts to make the noise.
Now hold your finger right where those bubbles are.
Here.
And one right next to it, see it?
Yeah, here.
Yeah, and one up to the left a little bit. Over to your left.
Over here.
Not that far, right in the center of the tube.
Just about right here. It starts
Right below,
to
there,
down.
see that? Now, see that little thing on the side of the test tube?
You mean the little scratch? The little
Yes,
dot?
that's a little tiny scratch.
Mm-hmm.
Why would you think that they would come from a little point like that?
You mean the heat is sort of like in that one spot?
That's
caught
right.
Spot?
The scientists aren't positive why this happens, but here's what they think is happening. They think that when you heat up something, a pot or a test tube or anything like this, the heat seems to be concentrated at little points. Now, there's another one right, I just boiled it over. Whoops, I better stop. Now, there you can see the little point. See it right there?
Over there.
They feel that the surface of the glass or the surface of the metal has a little hole in it, or perhaps a little point sticking up, or some kind of impurities where the surface seems to be hotter. And that's why, when it starts to boil, it seems to boil vigorously from specific points, and it always is the same points. You see that?
Yeah, it seems to
Now
fit in a little dent.
I'll raise the torch a little bit to see if I can get that scratch to boil again.
Here's a scratch, so
Yeah, right there.
it should start around there.
Whee! I'm boiling it over, and it's running down the test tube.
Going so fast.
There it
There
is.
it is, right
Right
there.
there.
Same spot. So once it sort of gets its little place there, keeps on going.
Now notice that it's hard to follow an individual bubble there because they all are coming so fast. And notice up above, too, you can tell that the bubbles aren't really round, are they, as they go up?
No, not really. They sort of go in all shapes.
Well, now, I took some high-speed pictures of this kind of boiling also, using that same sort of camera. And notice how quickly it stopped?
Yes, it
It cools off very, very quickly. But I used instead of a test tube like that, I had a flask, and I put the same sort of torch down at the bottom. You want to come around over here? And I started the thing boiling, and now we are slowing down the action of the boiling by about 100 times. So let's take a look at what happens when you concentrate on the bubbles themselves. Now, see, it's right down here at this point. Let's start with, there's one, see?
Yeah.
First it's round, now watch what happens to it.
It's getting bigger.
Getting bigger and quite flat, and then very distorted. Now they blend together, you see them?
Getting higher.
Now watch down here again.
And they form more and more.
Now why should the bubble get so distorted like that? You mentioned it when we were looking at the other one.
Well, the cool water around it just keeps on contracting it, and then the hot air is pushing it up, so I guess they have like a little struggle there.
Watch what happens when it hits the top surface now.
It tries to break through. There, it did it.
Yeah, like that. So it's impossible to see this sort of thing when you just watch a pot boiling, but when you take it with high-speed motion pictures and slow time down about 100 times, why then you can analyze very carefully. And scientists use this system to study the effects of boiling, and I'll tell you something about why they do that later. Now here's a close-up of the surface of the water.
It's like the surface of the sun.
Doesn't it though? There was a big finger of sort of looks like it's on fire, as a matter of fact, doesn't it?
Yeah.
Now watch what happens as this one comes up.
You see the steam coming up.
They're pretty designs, aren't they?
Yes.
Very nice shapes.
Doesn't look like boiling water.
No,
when
it
you look at
doesn't. Well, in the first place, I'm projecting a negative. I used the original film that was right in the camera, so that everything that's white would normally be black, and everything that's black is normally white. So that means the bubbles are all white. So that makes it look a little different. But the important thing is not really the difference in color, but the shape of the bubbles and the very interesting effect that takes place on the surface of the water. There's a huge one.
Cool air has a lot to do with it.
Yes,
Not
of
only
course.
making it contract, but the different shapes.
Part of this effect up here may be the water on the side of the glass. You see it? Because there's and see the interference patterns here?
Yeah. Please.
Okay. So boiling is a lot more complex
I never knew it was like that.
than just bubbles going up. Now I have another kind of effect for you. So far we've been boiling water, and what is the temperature of the water has been 212 degrees.
Yeah, 100 degrees centigrade.
Okay, you want to get up here. Now be careful of that frying pan because it's very hot.
Fry water?
Yes, if you fry water, look what happens to it.
Little pearls of water.
You see how the little pearls of water? I mean, let me, it's a little warm. I want to cool off part of the frying pan. Don't you look. Well, I wanted to cool it off, but I didn't want you to know which side I cooled off. It isn't cool enough. Don't look again.
Okay.
Yes, now you can look.
Okay.
Now notice there are two kinds of phenomena taking place here. See what's happening over there?
Yeah, well, the water is boiling away.
It's boiling.
It's hot enough to boil away.
Oh, you think that's hotter? That's hottest right there? Don't look. I want to cool it off a little more. Don't look. I don't want to tell you which side I'm
Okay.
doing. Okay.
Oh, well, when you put the water on the hot gas, of course it will boil.
When you put the water on the hot frying pan, it's boiling over here, right?
Right.
But what about what's happening over here?
Well, that's probably not hot enough to make it boil.
Oh, I see.
So that it's cool, but it's not hot enough to make it boil.
So
it just
so this
boils
is the
around.
hottest part here?
Yeah, it boils right away.
I see. Well, now that's, you know what? That's a good theory. However, I think you're wrong.
What do you mean? I mean,
well,
doesn't it boil at hot
Yes,
temperature?
it boils at hot temperature, but I think that's the coolest part of the pot. Here, I think I can show
Coolest?
you. Yes, I'll show you how. I can prove it. Notice that they form little balls like this
Right.
here in the center part. Well, I'm going to form those same sort of balls, and this time we'll look at them, however, with that projector over there.
Okay, we can take a look and
So
find out.
Yes, so we can take a look and find out. Instead of having a frying pan, however, this time I have a soldering iron. Here's a soldering iron, which I put in a clamp. And you see here I put a little piece of copper out here, so that's going to be our little frying pan.
Oh, okay.
So I'll take the test tube out of here.
It seems all right that the hotter part would boil away.
You'd think so, all right, but now there's the little frying pan on the end of the soldering gun. Now I'll put some water on it. Okay, now I'll turn on the soldering gun.
It
What should happen?
Boil away.
All right, watch. Getting hotter.
See a little bit of steam.
A little bit of steam. There it goes, right?
It's soon going to be out. Just
Okay,
about
now it's
boiled
all boiled away. Now the gun is obviously getting hotter. I'll now put on another drop.
Why doesn't it just lay down flat and boil away?
Hang on, I want to tip this up just a bit. Now notice it's getting hotter and hotter, and you hear that sizzling like we heard in this frying pan.
It's getting hotter?
Yes, but
But
the
if
iron
it's
is getting hotter and hotter. Now look at it.
Yeah, but if it's over 100 degrees, then it should boil away. Why is it in a bowl?
Yes, the iron is still getting hotter all the time. In fact, look at it jumping up and
I guess I
down.
was wrong. I guess the hotter it is, it just forms a ball?
Why?
Away?
Why should when the put water onto a very hot surface, doesn't it boil away?
Doesn't seem like it's even touching it the way it's rolling around.
Notice it's vibrating.
Mm.
Why would it vibrate?
Well, it's got to have something. Well, the heat. It's forming heat. Steam.
All right, let's.
To make it bounce, then there's something going by it.
All right, what could it be?
How about the air? Couldn't the air shield it?
Well, maybe. But think about this. What happens when that drop of water touches the hot end of the soldering iron?
Well, it's supposed to boil away and form
Okay,
steam,
now if it
but
does,
it's not.
if it does touch and form steam,
Yeah.
and the steam forms quickly, couldn't that be the shield?
You mean the steam? Its own steam is protecting it?
Yes. That ball of water is sitting there on a layer of steam.
It has its own shield?
That's right. And as the size and shape of the ball of water gets to be the right mass, the steam constantly vibrates it up and down. See how it's bumping and jumping all over the place?
So the hotter it is, it forms the steam to protect it.
Yes. In fact, scientists have named the two kinds of boiling we've seen before. Remember when I had the test tube there and was boiling from a point? They call that nucleate boiling, from a nucleus or some kind of little bump, a little point. This is called film boiling.
You can see why. The film, like the steam, would be the film protecting it.
And surprisingly enough, film boiling is very inefficient because you can see the drop is not boiling away.
Yeah, by the time it does boil, it'll be later
So
than the other.
scientists have studied this because they use water to transfer heat from one place to another in a steam engine or in nuclear reactors. So they've studied very carefully the amount of heat that is necessary to form steam in the first place, and then what happens when the temperature goes higher. And you can see here that if you wanted to make water into steam, that you should not get it too hot.
No, not too hot, or else it'll protect itself.
Yes, a layer of steam forms around it and protects it so it doesn't boil away.
Imagine scientists going into boiling water so simple.
Now, have you ever taken a hot nail or a hot poker or something and plunged it into water?
Yeah, anything that is hot, you just put it in water right away.
What
It goes,
happens?
Shh, and steams. Anyway.
Well, I'm going to do that same thing, but this time in the projector. And you'll be surprised, I think, at what happens there, too. Let's wait till that one gets a little lower. And meanwhile, I'll fill up my flask with water, and or my test tube with water, and lower it so we can look at the top part of it. Bubble gone yet? Not quite.
No, it takes a long time.
But notice it is getting smaller, so obviously it must be changing to steam.
The steam must be getting through to change.
Okay, watch it. Watch it.
It's getting smaller and smaller.
Notice, by the way, it's also acting as a lens. The light's going through it because it's a little water drop lens.
Oh, I see. That's that light in the
Yeah,
middle.
that's that light. I'm getting it out of focus at the moment. Okay, goodbye. Goodbye.
It's just sitting there.
There it goes.
It's bouncing.
And this is what happens in the frying pan, too.
Bounces around.
Oh, the heck with it. I'll get it out of there so we can go on with the nail. Watch out, that soldering gun is hot.
Okay.
Now, here's that test tube again. And I have a hot nail over here in a little furnace. And I'm going to take the hot nail and plunge it down into the top of the test tube, and you watch what happens.
Yes, very fast. The water starts to boil. There's that noise that I said.
Okay, well now, when you plunge it in so fast, it happens too fast so that you can't see what's going on. But I took some high-speed motion pictures of this, too. So let's get set and take a look at what happens when you plunge a nail into water and take pictures of it at 2,400 frames a second. Now here is a sort of a flat container that I put it in. And of course, when I put it in, the action is very slow, too. Here it is. And I went just as fast as I could go. And look how slow it appears here in this high-speed film. We're going to cut to a close-up of it now so that you can see what happens around the edge.
See, it's boiling the water away. It's near it. Water near it.
But the boiling that you're seeing here, would you suspect that this is nucleate boiling, in other words, from little points, or film boiling?
Well, it's not nucleate, that's for sure. It's not coming from a certain point. I guess it would be the film because this is cool water.
That's right.
And I guess as soon as it starts to go up, the cool water contracts it, so it's a film there.
All around the whole edge of the film here, or edge of the nail, is a film of steam. And this is what keeps this from boiling away so fast. Notice the bubbles don't rise because, as you pointed out, the water is cool, so it collapses the bubble. All these little pieces here are probably from pieces of the metal, because when you heat it up, it oxidizes, and then when you plunge it into cold water, it breaks away.
So that's the nail.
And notice down here in the bottom how
Yeah,
they're trapped down there. So when you plunge a nail into hot water, you get film boiling first, and then as the thing gets cooled off, you get into nucleate boiling. Okay. Well, now let's go back and take a look at that frying pan over there and
Okay.
see if you can tell me which side was which.
Yeah, I guess it was different.
Okay, don't look. I want to cool it off again.
Okay.
Turn.
Ooh, very nice.
Your film boiling over there?
Okay.
Yes, you can.
All right.
Which is the coolest side?
Over there would be the
Yes.
cooler side.
Correct. You can
And
see.
here would be warmer, hotter rather.
Let me we'll get that bunch of water down there. Yeah, got to cool it off again. I'll cool it off so you can see it though. Now, which is the hot
Yes.
side?
This is the hot side where
Yes.
this has a film.
And notice that the whole bunch of it, a whole big lump of it, goes all around together. Why doesn't it boil away?
It all has a film. It's all gliding on it.
That's right. Underneath this whole blob of water is a layer of steam. And why do those bubbles form in the middle?
Wasn't that the steam coming up?
Yes. When the blob is
Sneaks
big
up.
enough, the steam can't get around from the outside, so it forms a little bubble. And over there, however, it's cool.
Yeah.
So it's just the opposite of what you thought.
Yeah, I guess it was.
Okay, now the pan's getting hot again. And why does that noise when I drop the drops in?
Well, that's before, like when it contracts. Contracts, and it makes the noise. Just gliding around here. I bet it'd probably
Completely frictionless. In fact, watch. If you try this at home, be very careful because the pot gets awfully hot.
just go around and around. Seems like it never even touches the pot.
It doesn't because it's on a layer of
Just
steam.
steam.
Looks like an amoeba or a snake or something. But doesn't that seem strange that the hotter the pot gets, the
Yeah,
less
the hotter.
boiling there really is?
So when I want to boil something, don't put it too high, else it'll never boil.
Okay, now what should happen when I cool it off?
When you cool it off, it should sizzle. and
Okay,
boil
let
away.
me try cooling it off. I'll put it over here. Cool it off. There, you see?
It's sizzling all right.
I'll put it over here on the other burners. And as it gets cool, it boils.
It loses its film shield.
You probably
There's
noticed.
one
You
there.
probably noticed that lots of times as you put water into a frying pan, it boils only when it gets cool enough. Now I'll put it back up here and let it get hot. Anyway, scientists have studied this whole problem of boiling, as I said, very carefully because it is very important in science that they know exactly what happens as the heat is transferred from the surface to the water itself. And if you want to really make little drops, get the frying pan very hot. If you want to make it sizzle, cool it off.